All right. Welcome back. So, we're going to go over a little bit more today. Today, we'll be going over LLM key terms and fine tuning. Before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So, large language models operate through fundamental constructs that process and generate human like language. Understanding these terms and controls is essential for configuring, interpreting, and optimizing transformer models. Here are some core LLM concepts. Tokens. These are numerical representations of words or word parts. Neural networks can't process raw text, so tokenization converts something like indivisible into indivisible. Most LLMs use subword tokenization algorithms like Byte pair encoding or WordPiece. Models operate on these token ID sequences, not the original text. Embeddings. These are multidimensional vectors representing semantic meaning. Words with similar meanings cluster closer together in embedding space. These embedding layers then learn during pre-training and capture fundamental word relationships. Top case sampling. So this picks from the K most probable tokens. Higher K values increase randomness. Top P sampling, nucleus sampling, picks from tokens whose cumulative probability reaches P. Higher P value increases diversity. These sampling strategies enable controllable text generation for creative or exploratory tasks. Temperature. This controls randomness in token selection. Temperature 0.0 always picks the most probable token deterministically. Temperatures above 1.0 produce more diverse and creative responses. The context window. This defines how many tokens the model can process simultaneously. Something like GPT-3 handles about 2,048 tokens. GPT-4 handles over 32,000 tokens. This matters for document summarization and multi-turn conversations. Max tokens sets the maximum for combined input and output. Exceeding this limit causes truncation or errors. So, what are some fine-tuning strategies? All right. Transfer learning. This customizes pre-trained models for domain-specific applications with limited data and compute. Fine-tuning starts with pre-trained models like BERT or GPT-2, trains it further on your labeled data, and updates all or part of its parameters. Full fine-tuning updates all layers using new data. Layer freezing freezes lower layers while retraining only top layers. Adapter layers inject lightweight task-specific layers into the model. Prompt tuning provides labeled examples as prompts without model retraining. Fine-tuning enables tone customization, creating models that respond with humor, empathy, or sarcasm. It adapts models for domain-specific tasks like legal contracts, medical reports, or technical emails. It powers classification for sentiment analysis and spam detection. It creates personas that speak like fictional characters or company representatives. Customer service applications fine-tune on past support transcripts for on-brand replies. Always evaluate for bias, hallucination risk, and compliance before deploying fine-tuned models. So, in a hands-on lab, you usually want to work with the tokenization for BERT tokenizer, and then try to convert between text, token IDs, token strings, attention masks, and special tokens. And then you'll get a visualization of the positional encoding using sine and cosine functions. We're not going to do this because it's going to take a lot of time, and I want to keep these a little more brief. But your basic setup would be using the SageMaker notebooks, deploying an input, and then testing the tokenization text within this and examining the details, which you can visualize through the SageMaker dashboard or through CloudWatch logs. Once you're done, remember to delete your resources so that you don't incur additional costs. A persistent endpoint will cost you money. So, what does that cost actually mean? Within this, you'd want to typically use the ML.T instances, which usually costs 5 to 10 cents per hour, depending on the region. But then remember the EBS storage adds roughly 10 cents per gigabyte per month. And then data transfer within the same region and S3 access, while free, the storage can cost. Hugging Face models are free since they're hosted on open repos, but you can always minimize costs by using a smaller instance for learning and stopping instances immediately after use. You can also run inference on CPU since this doesn't necessarily require GPU acceleration. So, for the exam, a couple things to remember. When questions ask about controlling LLM output, its diversity, or customizing models for specific domains, or understanding how transformers process sequential data, knowing these key terms and fine-tuning approaches will help guide you to the correct answer. So that's all we have for this one. Thank you for joining. Appreciate your time. Remember to hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.